Good day, ladies and gentlemen, and welcome to Bright Engineering. Today we are going to look at parallel circuits. In our previous video we did something about series circuits and then we explained it to the core. Now follow me as we do parallel circuits. Now when we are talking about parallel circuits, the simplest way we can explain is that when you have two elements that share two common nodes without meeting any other elements, those two elements are said to be in parallel. So for instance, when you take R3 and then R2 and R2 shares this common node, which is 1. They also share this common node, which is 2, and so they can be said to be in parallel. When you take R3 and then R12, they share this common node, which is 1, and they share this common node too, which is 2, without meeting any other elements. So R3 is in parallel with R2 and is also in parallel with R1, right? So now let's find our equivalent resistance. So in order to find our equivalent resistance, it means that we have to solve for one particular value for R, and we know from our basic studies that if you want to find the equivalent resistance for all three, it's just 1 over the equivalent resistance, which is R, equals 1 over R1, 1 over R2, 1 over R3, right? But then in simpler terms, I want to introduce you to how fast you can solve resistors in parallel in terms of twos, right? So first of all, we are going to take R3 and then R2, and then from there we will take the equivalent of that and then also solve it in parallel with R1, right? So follow me. So whenever you are solving for resistors in parallel and then there are only two, you just have to multiply the numerator and divide by the addition of their denominator, right? So say for these two resistors, we are going to get R eq of 1, that's equivalent of 1, is going to be R2 times R3 divided by R2 plus R3. We are getting 30 times 30 divided by 30 plus 30. I hope you understand that. Yes. So here we are getting 900 over 60. So we can just straight away cancel this out, and then we know that here 3 can go into this 2, and then 3 can also go into this 30. 2 goes here 1, and 2 goes here 15. So we are getting this to be 15 ohms. But then mind you, this is only for these two resistors, and I said that you can only use this formula when the resistors are 2. So now equivalently we are getting this total resistors to be 15, and we can find that one too in parallel with this resistor. So now our R, which is the total equivalence of the resistors, is going to be 30 times 15 all over 30 plus 15. Please, I hope you understand that. So here we are going to get 450 divided by 45, and this cancel this out, we are going to get 10 ohms. So now our total resistance becomes 10, right? Or alternatively, we can just say 1 over R, which is the equivalent, is 1 over R1 plus 1 over R2 plus 1 over R3. Here we are going to get 1 over 30 plus 1 over 30 plus 1 over 30. And then solving this together, we are going to get the same answer as this 10 ohms, right? So now, because we don't want to waste much time, let's use this for our calculations. So when you get this, what we have to now do is find the total current that flows through the circuit. And we know from Ohm's law that V is equal to IR, right? So our voltage has been given as 60, and then we don't have our current, but then we know our resistance. So we can just make I the subject and get I is equal to V over R. So we are getting 60 over 10. So it means our total current is 6 amps. So it means that the current that's going to flow through this is just 6 amps, right? So the current here is going to be 6 amps, and then 6 amps is going to flow through it. But then mind you, just like series circuit, for series the same current flow through all the resistors, but then for parallel it's not the same, and then we are going to introduce ourselves to something we called the current divider rule. So in our next video, follow us as we explore the current divider rule. Thank you very much for watching.